what is space-time? We're going to demonstrate a few things about it. It's the fabric of
Which and also causes gravity of objects. So like if you have an object, it'll like other things, smaller things will orbit around it.
Okay, so
That's how planet orbit works.
this will be
Matter or space time. So let's do a star with planets first of all. So we have our star right here. And so basically the star is a lot more dense than planets, so it pulls it in, and this like more than this. See, it just really goes deep because it's more dense. Planets will orbit the
This
star.
will be a planet. So it orbits. Now in space it would not lose energy, but
Yeah.
of course here it will.
Planets all eventually move the same way. Demonstrate that.
We have like still much light.
And so basically, if you throw them both this way, and they bump into each other, which they're not really doing that now, but
You need a
throw them out more towards the edge so they have more room. And then you have to, they'll all end up going the same way eventually. If you do it right, which is actually very hard to do.
It takes a lot of practice to get this one right.
But yeah, that's how all the planets in our solar system are going counterclockwise. And two stars with equal density. So
Last one's broken.
they both have the same mass, like those two, and usually come towards
If
each
you
other.
put them in, they will. I think Spiro's
Spiros
right
won't
now,
really
so
work
they
that
will.
well.
But they would roll towards each other.
That's
of
true.
course.
So basically we have, let's pretend these are stars. So if we have them, they'll roll towards each other like that. So as long as, well, if they're very far away from each other, they have a less chance of actually rolling towards each other. But,
We'll go into this star right here.
now moons. Now this is really fun. So let's say you have yourself a planet right here, very large planet, and then this is a moon right here. If you actually throw it in there, it'll orbit it.
It's
Unless
like
it loses
representing
energy.
like the sun, like which is the star, of course, and then
So,
Earth and Moon.
so they will just simply orbit the planets, and they always have to be smaller than the planet. That's basically like, it has to be, like if you want something to orbit something else, it's got to be larger than it. So, yeah, this is really fascinating.
Did it do it?
Yeah.
Black holes.
Yes, these are extremely dense. Now, where's the black hole? So we have ourselves a black hole here. And now they're extremely small and have extreme gravitational force, so it's going to be like way down here. All the way down here, as you can see. Now, if you were to set a planet on it,
That's nasty.
it will just go
Rip.
instantly.
Straight in because of the
No. Yeah, the gravitational force. Now, planets or stars can actually still orbit black holes,
but
because
eventually they will miss.
yeah, always.
This is what that's what
Oh
NASA
yes,
says
dark
about
energy.
it.
So,
So it's pretty much like a
so we have
bolt
ourselves
in space-time, and
right
so
there. So basically, if we roll something onto it, like this, it'll always go away from it.
if there's an orbit happening, this can mess up the orbit because of the because of like the bulge, and so it
It
just
won't-
completely
it just-
messes up the orbit.
So yeah. Not much is known about dark energy because
The
it's
energy will
really hard
also
to
pull
see.
things apart. So if we have,
two things,
yeah,
they're just away from each other,
No, but it's fine.
which could be what's holding up this entire A and B. And as we said earlier, it's a bulge in the space-time fabric, and can interrupt systems, and the energy pulls things apart. So here's our bonus right here, the Apollo space program.
so, you know Apollo, they sent a,
They sent a
rocket.
spacecraft all the way to the moon.
so one
Why
will
did it
be
turn
Earth, and the other one will be Moon, because it came from Earth and to the Moon. The path that they took to the Moon is actually sort of like an infinity.
Yeah, it's actually very hard to do. That's why a lot of
There we
Apollo
go.
missions fail.
So that's pretty much what it is.
So basically, it orbits around the moon, and then it lands its little
Payload.
it lands its little Eagle spacecraft thing. So that goes on the moon, and then it comes back up to the Apollo thing, and then it comes back around. But, yeah.
That's the SAS right here.
And here's our bibliography. Oh yes, we also forgot about neutron stars. Neutron stars are like awesome because they're even denser than any other thing in the universe.
Black
Even
They're called
denser
neutron
black
stars,
holes.
and they're
They're the densest thing without turning into a black hole.
But basically, what it is it's like small. Small is like a large city on the planet Earth. So it's like a lot smaller than Earth. So basically, it's going to be like absolutely tiny like that. And so it'll go way down here. And anything that goes onto it will like become like liquid. So it compacts and so much.
And you weigh a lot on a neutron star.
But any questions?
It's too much.
So the neutron star is the second densest thing to a black hole.
It's a little more dense than a black hole.
So it can pull a black hole into itself, or does it go into a black hole?
It gets a really confusing because neutron stars you can't really see them, just like black holes. Yeah. So
So
yeah.
if they went together, would a black hole go into a neutron star, or a neutron go into a black hole?
It's really confusing.